Hello everyone. In this video, I'm going to discuss the solution to example 7 on relative equilibrium of liquids. So this is the problem. An open rectangular tank is full of oil of specific gravity 0.82. The tank is 1.5 meters long, zero point 0.6 meters high, and zero point 0.9 meters wide. It is accelerated parallel to a pair of longest sides. Determine the amount of oil spilled in liters for the following situations. So first situation, the tank moves at a constant speed of 120 kilometers per hour. Second, the tank is accelerated at the rate of 3 meters per second square. The tank is accelerated at the rate of 5.4 meters per second square. And the tank is decelerated at the rate of 3.6 meters per second square. So first, let's draw the details of the tank, including the content. So 1.5 meters long, zero point 0.6 meters wide. And this is the oil. So assuming acceleration is positive rightward, so if it is decelerated, negative if decelerated, so it's leftward acceleration. That's the other way around. So for the first situation, the tank moves at a constant speed of 120 kph. So it means that if the speed is constant, then the acceleration is zero. The slope is defined by tangent theta equals ax over g, and in this case ax is zero. Therefore, the slope of the surface, oil surface, will remain horizontal, and therefore no liquid will be spilled. So the answer to the first question, because this is the formula for the slope of the resulting surface, then it is equal to ax is 0, so therefore no liquid, no oil will be spilled in the first part. Then for the second part, the tank is accelerated at the rate of 3 meters per second square. So before that, let's compute the slope of the surface when the surface intersects exactly here at the bottom right corner, and we will call that theta c. So tangent theta c from the figure is 0.6 over 1.5, and 0.6 over 1.5 is zero point 0.4. Then in this problem, tangent of theta 2, let's call the angle, the slope as theta 2. So tangent of theta 2 is ax3 divided by g, 9.81. And this is equal to 0.3058, which is less than 0.4. So therefore, the surface will cross above this bottom corner somewhere here because the slope is lesser. So it should look like that. And this is the angle that the surface makes with horizontal. So a certain amount will now be spilled. This portion will be spilled is theta 2. So this is theta 2. The angle that this surface makes with horizontal is also theta 2. So I'll just define it there. We will call this height y sub 2. So that's replaced by air, and it is the volume that is spilled. So we will call that y2. So from the figure, tangent theta 2, which is 3 over 9.81, is also y2 over 1.5. So y2 over 1.5, so solving for y sub 2, it is 0.4587 meters. So from here, we can now compute the volume of oil spilled, which is this portion, because this is replaced by air, and this is just volume of this triangular wedge. Then the volume of triangular wedge is simply area times width perpendicular to the board, 0.9. So 1/2 of 1.5 times y2 times 0.9, then times 1,000 to convert it to liters. So volume spilled is 1/2 of 1.5, y2, which is 0.4587, times width 0.9, then times 1,000. So volume spilled in part 2 is equal to 309.6 liters. Then in part 3, the tank is accelerated at the rate of 5.4 meters per second square. Let's call the slope theta 3. Let's evaluate tangent theta 3, which is ax 5.4 over g 9.81. And this time it is 0.5505, which is greater than 0.4. So that means it is tangent, or theta 3 is greater than theta c. So therefore, the resulting slope would be somewhere here, crossing the bottom, as shown in the figure. And this is theta 3. And this is the volume of oil that is spilled, which is area of trapezoid times zero point 0.9, but that's a long process to do. I- Instead, we will call this distance x, and let's compute for the volume retained. So the volume spilled is original volume of oil in the tank, which is full volume, minus the volume that is retained in the tank, because this is represented by oil that is retained. So we will call this distance from this intersection at the bottom to this left corner, bottom left corner here as x. Then tangent theta 3, which is 5.4 over 9.81, is also zero point 0.6 over x from the figure. So from there, we can solve for x. So x is 1.09 meters. So the analysis is volume spilled is original volume of oil minus volume retained. Volume retained is simply 1/2 of x times zero point 0.6 times zero point 0.9, while the original volume is 1.5 times zero point 0.6 times zero point 0.9. So volume spilled is original volume 1.5 times zero point 0.6 times zero point 0.9 minus 1/2 of 1/2 of x 1.09 times zero point 0.6 times zero point 0.9. Then the whole these two terms should be multiplied by 1000 to convert it to liters. So volume spilled is equal to 515.7 liters. So that should be with sense because it should be greater than the preceding answer. Then the tank is decelerated at 3.6 meters per second square. This is supposedly negative, AX negative, but we'll just make it positive. What we change is just the slope. It is opposite to this, so it is going to the right. But let's evaluate tangent theta 4 first and compare it with zero point 0.4 or theta c. So 3.6 over 9.81, it is only 0.367, which is less than zero point 0.4. So that means the surface will be above this bottom left corner to that upper right corner there. So this is the amount spilled. This is the oil that will be spilled also. And this is this angle with the horizontal of the surface is theta 4. And therefore, tangent theta 4, which is 3.6 over 9.81 equals, we will call this y sub 4 over 1.5. So tangent theta 4, which is 3.6 over 9.81 equals y4 over 1.5. So y sub 4 is equal to 0.5505 meter. Then finally, volume spilled is this volume of triangular wedge. So 1/2 of quantity 1.5 times y4 0.5505 with perpendicular to the board zero point 0.9 times 1000. So volume spilled is equal to 371.6 liters. So that's all for this problem here. This is a simple one because the tank is originally full of liquid or oil.